Okay, so what everybody's been doing for just a moment is taking this system and solving it, whichever way they decided to. So I'm going to show you two ways. First one, I'm going to take each one of these and solve for y. Okay, so if we do it this way, we would just be using substitution. So we would get 3x plus 2 equals 2x squared. Now we have a quadratic. Whenever you have a quadratic, you set it equal to 0 to solve. So we get 2x squared minus 3x minus 2. And so we're going to factor this. And this is going to factor into 2x. And we need a negative 3. And a positive 1, that gives us negative 4, and the positive 1 gives us a negative 3. Okay, so I got x equals negative 1/2 or 2. Did any of you get those two?
I got those two.
Okay.
And I did not copy off the corner.
Good. How many of you did elimination? And you just took the second one and changed some signs?
I made them equal to each other.
And so we could do it that way. Awesome. So we would get 2x squared minus 3x equals 2. And then we'd set it equal to 0. And you get exactly the same thing we had here. So it would solve the same way. Now, am I done? X equals negative 1/2 and y equals 2. Is that it? No, we have to plug it back in. All right. Now, when we plug it back in, we want to plug it into the equation of minimal degree. And then we're going to test it in both of them. So if I plug in the negative 1/2, if I plug it in here, it's a little easier to see. What do I get out? Positive 1/2. So if I plug negative 1/2 in here, do I get out a positive 1/2 for y? Yeah, because if I plug in negative 1/2 and square it, I get positive 1/4. Positive 1/4 times 2 is 1/2. So 1/2 minus 1/2 is 0. So it works for both equations. Now the second one, if I plug it in here, I get 6 plus 2 is 8. If I plug it in here, 2 squared is 4 times 2 is 8. Get the same answer, don't I? All right, so these are my solutions, aren't they? So what does that mean if I graphed it? If I graph that parabola and I graph that line, they're going to intersect in those 2 points. They're going to intersect at the point negative 1/2, positive 1/2, and then they'll intersect again at 2, 8. Okay, today in class, all I'm going to show you is solving algebraically. Because we know how to enter this part on our calculator under y1, and we know how to enter this on our calculator under y2, and graph them and find the intersection using our calculator. So I'm not even going to spend class time doing that. No, because I've already taught you how to use your calculators to do this. So you should be fine, even if we do different kind of functions, like these. So this is a cubic and a line. So if we're going to do this algebraically, since they're both already solved for y, let's just use substitution. Are you guys good with that? All right, so we'll sub this in, and we'll get negative 2x equals x cubed minus 3x. And so what are we going to do? We want it to equal 0, so how do we do that, Brian?
Add 2x.
Add 2x to both sides. So we get 0 equals x cubed minus x. Now what would we do to solve this? To find where this equals 0?
Minus plus plus.
If this were a cube and this were a cube, that's exactly what we do. But it isn't. It has a common factor though, doesn't it?
X.
Take out the x. And it leaves me with x squared minus 1.
Now we find our zeros.
And so we can. Or you could even factor this more if you like. X plus 1, x minus 1. So what are my zeros?
0, negative 1, and 1.
Okay, so let's plug them in. If I plug in 0 into this one, what do I get out? 0. If I plug 0 into this one, do I get out 0? Yes. Okay, let's plug in -1. If I plug in -1 into this one, what do I get out? 2. If I plug -1 into this one, I get out -1 plus 3, which is 2, another solution. So if I plug in 1, I get out -2. If I plug in 1, I get out -2. So we do have 3 solutions, which means if I graphed it, this would intersect in 1, 2, 3 points. Now, not every time you get an x value does it end up being a solution. It doesn't always work. So let's look at a case where they might not all work. Yay! Square root.
The negative ones won't work.
So it's ooh.
Called it.
It'll be imaginary. I thought this was.
Now a negative x may work. You just can't have a negative under the square root. So we're gonna have. So we'll have to think about this.
Negative.
All right. So they're going to solve for y. Going to use substitution again. All right. Who has an idea about what we do first?
Square.
Square both sides. Square both sides. Okay, so when we square this side, we're going to get x plus 3.
4x squared.
Okay.
4x squared plus 16.
How about minus 16x? Because it's -2 times 4 doubled. And then plus 16.
Okay, look at that.
Well, look at that.
You square the first, you double the product, you square the last.
Yeah, it's all coming back.
Okay, and then we're going to set it equal to 0. So we're going to get a -17x here and a positive 13. Okay, that kind of looks a little ugly, except 13's prime, which makes it really simple. There's only one way to do it. It's 13 and 1. And I see if I do 13 and 4 together, don't I get 17? So I'm going to put the 4 and the 13 together. So that gives me -4x, and -13x is -17x. Okay, so my solutions are 13/4 or 1. Okay. If I plug the 13/4 in here, 13/4, I'm going to get -13/2, right, when I double it, which is like -6.5. What is -6.5 plus 4? Do I even need to test it?
No.
No, because this answer has to be what? Positive. Yes. This answer has to be greater than or equal to 0. And I got something that is negative. So is this possible?
Extraneous.
Extraneous. Okay, now let's try 1. If I plug in 1, I get -2 plus 4 is 2. If I plug in 1, I get the square root of 4 is 2. So this is my only solution. So this square root and this line cross in at 1 point. It is possible to have a square root and a line cross in 2.
Yeah.
Or a 0. Right? So if my square root function looked like this and my line was over here. Let me draw a better square root function. I could have a line cross through like that, couldn't I?
Ooh.
Where you get 2. Okay.
You could have.
So there, it's possible to have 2, just not in this case. This one doesn't. All right. Now, our another new one we studied, absolute value. And to make it fun, let's do it with a quadratic, not just a line. So let's take a look at this. We know how to start. We're going to use substitution. Okay. I'm going to solve for the absolute value here, and then we're going to talk about why I chose to do that.
Why?
So what we're going to do is move the 5 over. And then divide by the 3. Whoops. That's a 3. There we go. Okay. Now, if x were positive or negative, wouldn't this become positive?
Yes.
So what I would do is I would set this equal to the positive, or this could equal the negative. Does that make sense?
No.
What's the absolute value of positive x?
Positive x.
X. What's the absolute value of negative x?
Positive
X. Yeah.
So why would you set it equal to the negative x?
Because if I don't, then I'm neglecting one whole side.
Absolute value of positive and negative x is x. It's very simple.
Okay, so here I get negative 2x squared plus 5 equals 3x. So 0 equals 2x squared plus 3x plus 5. Here I get negative 2x squared plus 5 equals negative 3x. So 0 equals 2x squared minus 3x plus 5. No, minus 5. These are both minus 5. Sorry.
Yes.
Okay, so this factors to, okay, I need a 2x, and I don't want to multiply it times the 5, so 5 needs to be with it. And the x and a 1, because that's the only way I can get 5. And so I need the 3 to be positive, so the bigger number needs to be positive, the smaller number needs to be negative. Okay? And this is going to factor the same way, except I think we're going to switch our signs up. So it becomes 2x minus 5 and x plus 1. Okay, did yours factor like mine? So what are my possible solutions? Possible x values at the intersection. Negative 5 halves, positive 1, positive 5 halves, negative 1. Okay, let's test them. If I plug negative 5 halves into, and it really doesn't matter, we're just going to have to test with both. If I plug it in here and I square it, and I multiply it times negative 2, isn't it going to be a negative number? Okay. If I plug it into the top one, it becomes positive, right? And then times that would be 15 halves. So now we're at 15 halves. But then we have this minus 5. Is it minus 5, 10 halves? So here I got 5 halves, which is positive. So when I plugged it into this one, I got a negative. But when I plugged it into this one, I get a positive. Did I get the same thing?
No.
No. So is this a solution? No. Okay, let's try 1. Plug in 1, get out negative 2. Plug in 1, get out negative 2. Works.
I get tired. Peanut gallery over here. It's giving me a hard time.
Okay. Plug in 5 halves. Do you guys see that when I plug in 5 halves, the exact same thing's about to happen? Because this becomes positive, and when I squared the last time it became positive. So I'm the same, I'm going to get a negative here and a positive here. So doesn't 5 halves work? No. Okay. What about negative 1? Okay, when I plug in negative 1, what do you get out? Negative 2. And that one works.